Hi guys, welcome back to the channel. Today on Alex Builds we're going to be doing part 4 of our Revell Into Darkness Enterprise build. So part 4, what we're going to be doing in part 4 is we're going to be working on the lights. So today we're going to be doing the strobe and navigation lights. I'm going to be using an Arduino Uno for this. So let me show you what these are. So this is an Arduino Uno, and what we're going to be doing, this is a microprocessor in the middle, and we get all these pins down the side here. So down here we've got pin 13, 12, 11, 10, all the way down to pin number 1 at this side. This is our digital side. Here we've got our power. So we've got our grounds and our 5 volt and a 3.3 volt. There's also a ground over this side as well. And down the bottom we've got some analog pins down there. We're not going to be using them today. One thing to note about the Arduino is that pin 13 has its own LED wired in with its own resistor. So whenever we plug anything into pin 13, we do not need a resistor for that, but we will do when we actually come to build the circuit itself. So remember that. And this is a breadboard. This is what we're going to be plugging all our components in. I'll show you a little bit more about this in a bit more detail in a sec, but basically we've got these parts here down the side where we can put some components. We put some power down here. It's all separated by this gutter in the middle. And we also need some of these. These are jumper cables. These are what we're going to be used to plug in. So we can plug something into our Arduino and our breadboard, just like that. We can jump them across. So that's what we're going to use. A few other things that we need. We're going to need some resistors. For this sketch I'm going to be using 100 ohm resistors, which are these ones here, and also LEDs. For this I'm just going to be using white LEDs, and it's important to note that this shorter leg is the negative leg. So this is the leg we're going to put our resistor on when we put it in our breadboard. As I said, we're doing our strobe and navigation lights today, and then probably next time we will do our warp and impulse engines. So each one, I was going to combine them all together and have them in the one sketch, but then I thought I wanted to keep it simple because I don't know too much about Arduino. I'm still learning. I've only just started. This is my first delve into Arduino, so I wanted to keep it simple, and I wanted to keep it simple for anyone watching out there. So if you are a real whiz on Arduino, be kind in the comments down below, because I'm not the best at Arduino yet, as you'll probably see in this video, but it's enough to get our sketch around. So our ATTiny is what we're going to use. We're going to use a couple of ATTinys as a microprocessor, and we're going to build them into a PCB board. Once we've got all the sketches, we'll build all our ATTinys and whatever else we use into our PCB board, and that will run all of the sketches together. Rather than program it all together, we're going to program a few different ones and have it ran on the same circuit board together, if that makes sense. So yeah, so let's move on, and let me show you about the breadboard. So the breadboard is basically, it's a continuous strips of linked together holes. So there's loads of different linked together holes, but it's critical to understand which holes are linked together. So on the left and the right hand sides we have our vertical bus strips that are continuous down the side. These are for our positive and negative connections. So next we've got these horizontal strips that are also linked together, and you've got yellow on the left hand side and green on the right hand side. They do not connect together through the middle because there is like a middle divider through there to break the strips up so you don't short circuit out any microchips or switches or anything that you're putting in there. So this is normally called a gutter. Anything that is put along these strips in a horizontal way will be linked together also. So if you put two things in section number 5, they will be linked together. So first up, what you want to do is you want to connect your ground to the ground pin on the breadboard to the Arduino. Then you can take your first LED and not go in horizontally across, but you want to follow the ground all the way down and have it horizontally so it straddles 2 strips, not the one, because you don't want these linked together. So the way you can put your components in is you use the horizontal holes that are going down, and you need to straddle two of them to program an LED. One of them, we'll put the LED in, we connect our ground up, and once we've connected our ground up, we can connect this LED to the ground and then to pin 13. This is going to be our navigation light, and we're going to program this to be a double blink. Because this LED is plugged into pin 13, we do not need to put a resistor in there, because pin 13 has a built-in resistor for its own flashing LED that's built into the actual Arduino itself, so we do not need to put a resistor in here. But if we put our other two LEDs in, we do need to have resistors put into these, so we can connect these up with the resistors going to the ground, and then we can connect the first one up to pin 13, second one to pin 12, the third one to pin 11. If you open up your Arduino and open up a new file, this is what you'll be presented with, and you'll have 2 points to input code. You have your void setup, which goes between these two curly brackets here and here. So anything you want to put, like what pins you're going to be programming to, goes in here, and your actual code to run the program goes between this one here and this one here in the void loop. So we have our Arduino IDE program running, and we have a brand new sketch open. So what we're going to do is a basic blink sketch basically. So what we need to do to start off with is tell it our setup. So we need to do some pin modes, which if you do it in the right way, pin with a capital M, pin mode, and that will turn orange to signify that you spelt that right. So make sure that that M in the middle is a capital M. Then we want some curly brackets, and we want to tell it which pin this is. So we're going to start off with pin 13, which is our navigation lights, and this is going to be an output pin because we're sending data to this pin. And that's how you close the close brackets and one of them after it. If you put a double slash, we can write what it is. So this is our navigation LEDs, and now we know what they are. Now we need to do exactly the same for our strobe lights, and these are on pin 12, and this is also an output pin. Close brackets, one of them, and we'll tell it that these are our strobe lights. These comments that are in grey here will not show up in the code. The computer won't read them. They only read everything in black, orange and blue. So we don't need to worry about that's just for us, the grey comments. And lastly, we've got one more set of LEDs, which is pin mode, and this is in number 11, and this is also an output pin, and this is for the lights that are going to be constantly on, constant on LEDs. So now we've got our 3 pins all set up in our setup menu just here, and now we can go over to the void loop. So first thing we want to do is turn these on. So we need to go digital right with a capital W, digital right. So we want to tell it pin 13, we want it to turn it on by saying turn it high. On is high, off is low. So we want to do that with all 3 of these. So I'm going to copy it, and I'm going to paste it a couple of times here. So paste and paste. Doesn't matter about any spaces, but if you want to be neat, just delete that down. I'm going to change this 13 to a 12 and an 11. This is going to turn all of our pins, all of our LEDs plugged into these pins, it's going to turn them all on, turn them high. So now that we've got them all high, we know that our constant on LEDs, we don't have to put that one in again. So that's going to stay on forever. But these two, we need to write some code. So this one here, I want to double blink it. So I'm going to copy this one, put in a second, and we want to put a delay here first. So a delay, and we want 100 milliseconds. It takes 1,000 milliseconds for 1 second. And now we can paste, and we want to turn this one low. So that's going to turn pin 13 on, pin 12 on, pin 11 on, wait 100 milliseconds, and then turn pin 13 off. Now we want to delay that again. Delay by another 100 milliseconds, and then we can turn that one back on. So that is LED pin number 13 going to blink once, but we want it to blink twice. So I'm going to do it yet again. Delay for 100 milliseconds, and then I can paste pin 13, change the high to a low, just like that, and then we're going to put a delay at the end. So that's it coming on, off, on, off. So this time we want to go 700 milliseconds, just like that. So that is the first half of our sketch all written. So from here down to here, that's our first half of our sketch. So now we can just basically copy that, go underneath that one. I'm going to leave a little space just so we know that's the first half and this is the second half. So we don't need pin 11 to go high again because it's still high from the first one, and we don't need to turn it off, because basically what an Arduino does is this code will read it in a list type form from the top to the bottom. So it will start off here at this one here, and then it will work its way down reading the code like this until it gets to the bottom, and then it will go back to the top when it hits the bottom. So LED that's plugged into pin 11 will still be on. So we took that one out, and now what we can do is that's going to turn on. We need the delay there, and that's going to turn that on just like that. So the only other thing we have to change is this one here, because this one here is the same as this one here at the top, and it hasn't changed since this one at the top where it was high. So we need to change this one to low now, making sure this is all in capitals as well. So what this is going to do, all three of them are going to turn on. Pin 13 is going to blink twice, and then after pin 13's blinked twice, it's going to wait 700 milliseconds, and then it's going to turn pin 12 off, and then blink twice again, and then restart the whole code over again. And that is the first sketch written. So now we can click this icon at the top which says verify. So we can click that, and we're going to make sure that there's no errors in our code. So what we're going to do is we're going to call this navigation strobe. And that will save for us. Once that's done saving, we can send that to Arduino. So now it's told us that we've got an error before this. So I've missed one of these commas here, just here. So I need to put one of them there, and if I've missed it there, I copied and pasted it, so I've missed it there. So it's important to have these at the end of each one to make sure that your code will work. Now we can verify again, make sure it works this time. And there it's done compiling. So now we can plug in our Arduino. So we can take this and plug it in. So I've got the Arduino set up exactly the same way as we had on our breadboard. So we've got our 3 LEDs here. 2 of them have our resistors. This one has a cable jumped from that negative to the negative on here, and they're plugged in to the corresponding pins that we've just put in our program. So what we can do now is we can plug this in, and we can send the code to that. So let's send the code to it. And once that's done compiling, it will come up down here, done. And then we can have a look at our strobe and navigation sketch working. So now it says done, and we can go over to our board and look at that. We've got our constant on, our strobe light that blinks once a second, and our navigation light that blinks twice. So we've written our first sketch, We've checked and verified that it works, and it does exactly what we want it to do. So now we have to make it permanent. For that, we're going to use an ATTiny 85 to replace our Arduino Uno board. This is an ATTiny 85 here. It has 8 legs, 4 on each side, and pin number 1 can be identified by a small notch just to the right hand side of pin 1. So moving around anti-clockwise, we have pin 1, 2, 3 and 4 all down the left hand side, and then on the right hand side, going from bottom to top, we have pins 5, 6, 7 and 8. So they are going to be, our 5 volt and our ground is going to be on pins 8 and 4. Pin number 1 is our reset pin. ATTiny's pins numbers 2 and 3 are our outputs numbers 3 and 4. And on the opposite side, we've got our ATTiny pins 5, 6 and 7, and they are pins 0, 1 and 2. 0 and 1 have pulse width modulation, so we can do some fading in and outs on them if we wish. So first off, we have to go into our Arduino IDE, which we have open here, and we're going to install software that will change the Arduino into a programming device. So for that, we need to install the ATTiny software. So we need to go to File, down to Preferences, click on that. When that opens, you'll see a additional dialog box down here. So I will put a link in the description down below where you can copy and paste that into here. So I'm just going to paste that in now. Once you've pasted that into there, all we're going to do is click OK down the bottom. Now we've done that, we can go up here to Tools, select Tools, down to Boards, up to Boards Manager, and then we can scroll right to the bottom and our ATTiny should be in here. Just here. We can click that, click Install, and that will install for us. So now we've installed our ATTiny into our boards. It should appear at the bottom here. We don't want to select that just yet. We want to select that Keep Arduino Uno selected. So now we need to plug in our Arduino Uno into the computer. And then what we want to do is go to File, Tools even, no, File, Examples, Arduino ISP, and that will open a new sketch. You don't need to alter anything into this sketch, and then click Send, so it will send it to the actual Arduino itself, and this is going to turn it into a processor for us. So now that's done uploading, and we've unplugged our Arduino, we can go to Tools, Boards, and we can scroll down to the bottom, and I have two different ones. I have ATTiny 254585 and ATTiny 2444 84. Ours is an ATTiny 85, so we can click on that one, and that's going to change our board to an ATTiny just here. So next we need to take our resistor. This is a 10 ohm resistor, and this is going to go between the ground and the reset pin. So that is that in there. This step isn't essential, but it's good to be safe. So now we can start wiring up our Arduino to our ATTiny. So we're going to need our ATTiny pin 1 on here. We'll go to pin 10 on the Arduino. Pin number 5, which is this bottom one here, we'll go to pin number 11. Pin number 6 on the ATTiny, which is this one here, we'll go to pin number 12. Pin number 7, we'll go to pin 13 in here. And then we want to put we're going to use red wire for this, so pin number 8 on here, go into our 5 volt voltage, and we also want another one going from pin number 4, which is this bottom one here, into any one of our grounds. So I'm going to put that in the first one next to pin 13. So now we've got it set up and ready, what we need to do is go back over to here, go to Tools again, make sure our board is selected to ATTiny. Now we need to select the processor. We want ATTiny 85. And now this has got, we want to change this from a 1 megahertz internal clock to an 8 megahertz internal clock. So again, Tools, down to Clock Internal. We want to change this internal 1 megahertz clock to an 8 megahertz clock. Now we can go to Tools, Programmer, Arduino as ISP down the bottom, and then we can go to Tools again and click Burn Bootloader. So before we do that, we need to plug back in our Arduino. And now we can select Tools again and Burn Bootloader at the bottom. This may take a few minutes. Mine is already done. Alright, so now our ATTiny is ready to receive our sketch. So we go to File and we're going to open our sketch. So we don't want that one yet. Warp Impulse, that's going to be the next one. So we go to Arduino, and ours was the navigation strobe. So we're going to open this one. Now we've got our sketch open. What we need to do is we need to change these numbers on here, because these are for our Arduino. Now we need to change it to match our ATTiny. So I'm going to have this loaded on. The navigation lights are going to go on to pin 0. Our strobe lights are going to go on to pin number 2. Actually, I'll put this one on number 1. And our ready ons are going to be on pin number 3. So we can change that now. This one is going to be number 1. This one is number 2. And this one is number 3. So all of these 13s, we'll change all of these 13s down here to number 1. Just like that. And now it's ready to receive our sketch. So we've got pins 1, 2 and 3. 1 is going to flash, and then 2 is going to flash on and off. So now it's ready to be received. So we can check and make sure. So we go to Tools, let's go to our ATTiny with 8 megahertz clock, and now we can just click Upload, and that's going to upload our sketch to our ATTiny. Make this a bit bigger, and then we'll click Upload. Now it's compiling the sketch, and it's going to burn that to our ATTiny. Now our ATTiny has our sketch uploaded to it, so we need to remove all the cables bar the ground and the power cable, the 5-volt cable in pin 8 and 4. So leave them in, remove everything else out. Next we want to move the ground into the ground bar of the breadboard, and then a jumper cable going from our ground of a breadboard into the ground of our ATTiny. So now we can start building our sketch on here. So we're going to take some LEDs. So this is our first one. I'm going to put that one just in there. Remembering which one is the negative leg, and we're going to put some resistors in there now while we don't forget. So let's put the first one in just there, and we'll put another one in just here. And we'll put another one just here. And we don't need to power the positive rail on this anymore, because our power is now being ran by our ATTiny, so we don't need that anymore. So let's get our last 2 LEDs plugged in. We're going to check and make sure this works. So that's that one. Right, so now we need some jumper cables. We're going to need one going from this leg here into pin number 1, which was this one. Next we're going to put this one, so let's plug the one into the positive leg of that, into pin number 2 of our ATTiny, and the very last one which is this one over here, we can plug it to the positive leg of that into pin number 3, which is the second one down, which would be pin number 2 on the ATTiny. So there we go, that is that, all set up and ready to go. Now all we need to do is plug in the Arduino and hope for the best. And there we go. It is working and running off of the ATTiny chip. Look at that. That's it guys, that is part 4 complete, and yeah, we've written our first sketch for our scratch built custom lighting kit, and here it is here. It doesn't look much, I know, but when it's in the model it will look awesome and it will work awesome. I will put a graphic on the screen now where I have demoed this in the actual top of the sources section, and as you can see I've linked them together in series on the breadboard. So we have the 5 navigation lights blinking, the 1 strobe in the center, and we've got the 4 lights that are constantly on either side of one of the navigation lights. This is my first Arduino project, and I'm no master at it, I know, and I know there's a lot of people out there who are far better on an Arduino than me, but for what we need, I've got the basics down so we can do exactly what we need. And yeah, it's gone great so far, and I think it's going to work really, really well. I've already written the next 2 sketches, which is the warp and impulse and the warp the cell bazaars. I've already written them, they're ready, and I just need to do the video to show how I did that. So that will be coming very, very soon. So if you like this video guys, please leave a like down below, and if you haven't yet subscribed, please consider subscribing. Till next time guys, take care, and I'll see you next time. Take care, bye bye.